Welcome to the public exam review on Chapter 8 dealing with logarithmic functions. In this presentation, we will look at applications involving logarithmic scales. Here we will focus on applying the laws of logarithms to logarithmic scales, and we will solve a problem by modeling a situation with an exponential or logarithmic equation. We have 5 examples. In example 1, the Ch scale is used to measure the acidity or alkalinity of a solution. pH is defined as pH is equal to the negative of the log of H+, where H+ is the concentration of hydrogen ions, measured in moles per liter. We are asked, what is the pH of a solution with a concentration of H+ equals 4.3 times 10 to the negative 6? Look at the given equation. We are given that the pH is equal to the negative of the log of the hydrogen ion concentration. It is important to understand what the question is asking. We are asked, what is the pH of a solution? And we are given that the hydrogen ion concentration is equal to 4.3 times 10 to the negative 6. Substituting this value into the equation that is given, we have that the pH is equal to the log of 4.3 multiplied by 10 to the power of negative 6. This question can now be answered using a calculator. When you substitute these values into your calculator, you will get this answer to approximately equal 5.37. So the correct answer here corresponds with C as your multiple choice item. I think also you could have used your laws for exponents to answer this question. So I will do this solution using 2 different methods. In this case here, you can see that we have the log of a product. So we can rewrite that using rewriting it as the sum of 2 logs, where the pH is equal to the negative of, that can be written as the log of 4.3 plus the log of 10 raised to the power of negative 6. Note that there is no base given for the logarithms, so we know that it is considered to be a common logarithm with a base of 10. Again, using your calculator, you could determine that the log of 4.3 is approximately equal to decimal 6335 plus the log of 10 raised to the power of 6 to base 10 is equal to a negative 6. Simplifying what's inside the brackets, we have the negative of negative 5 decimal 3665. And the negative of that will give us a pH to approximately equal 5.37. So you could have used your calculator, which would have been the easiest method to use there, just substituting these points into your calculator, and you get the pH to equal 5.37. Or you could have used your laws of logarithms and rewrote the log of a product as the sum of 2 logs. Again, calculating this, you get the pH to equal approximately 5.37. In example 2, the magnitude of an earthquake M, as measured on the Richter scale, is given by M is equal to the log of I, where I is the intensity of the earthquake. The magnitude of the earthquake in Haiti measured 7 on the Richter scale, and the magnitude of the earthquake in Chernobyl measured 4 on the Richter scale. How many times as intense was the earthquake in Haiti as compared to the one in Chernobyl? Again, we are given an equation, and it is important to understand what the variables represent. M represents the magnitude as measured on the Richter scale, and I refers to the intensity of the earthquake. So if we look at both situations, first we have the situation in Haiti, where the magnitude, let's just look at the given information, the magnitude of the earthquake in Haiti measured 7. So we have 7 is equal to the log of I1. Let's let I1 represent the intensity of the earthquake in Haiti. So converting that to exponential form, we have 10 raised to the power of 7 is equal to the intensity of the earthquake in Haiti. On the other hand, we have the situation in Chernobyl, and in that case, the magnitude of the earthquake in Chernobyl measured 4 on the Richter scale. So we have 4 is equal to the log of I2. Let's let I2 represent the intensity of the earthquake in Chernobyl. Converting that to exponential form, we have 10 raised to the power of 4 as the intensity of the earthquake in Chernobyl. So then it's asking us how many times as intense was the earthquake in Haiti as compared to the one in Chernobyl. So the one in Haiti was more intense, so by how much? So we take the ratio of I1 divided by I2, and we will have 10 to the power of 7 divided by 10 to the power of 4. When you divide powers with the same base, you subtract your exponents, so we're left with 10 to the power of 3, which is equal to 1,000 times as intense. So the earthquake in Haiti was 1,000 times as intense as the one in Chernobyl. So this answer corresponds with D as your multiple choice item. In example 3, the sound level A in decibels is defined as A equals 10 multiplied by the log of I divided by I0, where I is the intensity of the sound measured in watts per square meter, and I0 is 10 to the negative 12 watts per square meter, which is the threshold of hearing. We are asked, what is the intensity of the sound of a fire truck siren that has a decibel level of 112 decibels? So in this case, the given equation is as follows. A is equal to 10 multiplied by the log of I divided by I0. So we have to understand what each variable represents. A is the sound level in decibels. I is the intensity of the sound measured in watts per square meter, and I0 is just simply 10 to the negative 12 watts per square meter. So the question is asking us, what is the intensity of the sound of a fire truck siren that has a decibel level of 112 decibels? So in this case, what the question is asking us, it's asking what is the intensity of the sound when the fire truck siren has a decibel level of 112 decibels. So basically what we are asked to do is to find the value of I when A is equal to 112 decibels. So substituting in this value for A, we have 112 is equal to 10 multiplied by the log of I divided by I0 is just simply 10 to the negative 12. So in order to solve for I in this equation, we will divide both sides of the equation, first of all, by 10. So on the left-hand side, we have 11.2 is equal to, notice that the 10s cancel, and you're left with the log of a quotient, I divided by 10 to the negative 12. Now we can use our quotient law for logarithms and rewrite the log of a quotient as the difference of two logarithms. Here we would have 11.2 is equal to the log of I minus the log of 10 raised to the power of negative 12 is simply a negative 12 because the base of your power is the same as the base to your logarithm. So solving that equation then for I, we will have 11.2, that will become a minus 12. Well, I'll just write the full equation first of all. So 11.2 is equal to the log of I, that becomes a plus 12. So then we have the log of I is equal to 11.2 minus 12. The log of I then is approximately equal to a negative decimal 8. So in solving for I, we have to convert it to exponential form, and I will approximately equal 10 raised to the power of a negative decimal 8. That value of I then is approximately equal to decimal 16 watts per square meter, and that is the intensity of the sound of the fire truck siren. I'll just indicate here that we had to, at this step, we follow up to here for our final solution. Okay, and in example 4, paleontologists can estimate the size of a dinosaur from incomplete skeletal remains. For a carnivorous dinosaur, the relationship between the length S in meters of the skull and the body mass M in kilograms can be expressed using the logarithmic equation 3.6022 log S equals log M minus 3.4444. We are asked to determine the body mass to the nearest kilogram of an Albertosaurus with a skull length of 0.78 m. Once again, we will use the given equation, and we have to understand what the variables represent. So we have 3.6022 times the log of S, and S represents the length of the skull, is equal to the log of M, where M represents the mass in kilograms, minus 3.4444. So let's look at what the question is asking. Determine the body mass to the nearest kilogram of an Albertosaurus with a skull length of 0.78. So basically what we are asked to find here is we are asked to find the value of M when S is equal to 0.78. So we need to substitute this value for S into the given equation. So we have 3.6022 multiplied by the log of 0.78 is equal to the log of M minus 3.4444. We could calculate the log of 0.78 using our calculator. So we have 3.6022 multiplied by a negative 0.1079 equals the log of M minus 3.4444. Simplifying, we get negative 0.3887, and we'll bring the 3.44 over to the left-hand side, making it a plus 3.4444 equal to the log of M. So then we have 3.0557 is equal to the log of M, and again converting that to exponential form, we have 10 raised to the power of 3.0557 will equal M. So the mass of this Albertosaurus then is approximately equal to 1,137 kilograms. And we have a final example where the logarithmic scale used to express the pH of a solution is given by pH is equal to a negative times the log of the hydrogen ion concentration in moles per liter. The hair conditioner that Alana uses is 500 times as acidic as the shampoo she uses. If the shampoo has a pH of 6.1, find the pH of the conditioner. So look at the given equation where pH is equal to the negative of the log of the hydrogen ion concentration. So we have pH is equal to minus the log of H plus. So now we are given the fact that the shampoo has a pH of 6.1. So if we look at the case of the shampoo, we could determine the hydrogen ion concentration of the shampoo. So the pH is equal to 6.1 equals a negative, the log, of the hydrogen ion concentration for the shampoo. So we have multiplied both sides of the equation by a -1. So we have negative 6.1 is equal to the log of the hydrogen ion concentration. Converting that to exponential form, we have 10 raised to the power of negative 6.1 is equal to the hydrogen ion concentration for the shampoo. Now we are told that the hair conditioner, this is another key piece of information here, the hair conditioner that Alana uses is 5 times as acidic as the shampoo. So using that piece of information, we know that for the conditioner, that the hydrogen ion concentration for the conditioner is going to be 500 multiplied by 10 to the power of negative 6.1, since it is 500 times as acidic. So then we can determine the pH of the conditioner using the given formula again. So it would be pH is equal to minus the log of the hydrogen ion concentration. So we will substitute in this value, a minus the log of, that will be 500 multiplied by 10 raised to the power of negative 6.1. We can use our laws of logarithms to come up with this solution, or you can simply plug those values into your calculator. And the pH of the conditioner is equal to 3.4. So that's the pH of the conditioner, and that answers the question that was being asked. Some key ideas here. We have many real-world situations can be modeled using exponential or logarithmic equations. Some useful tips on solving these equations are listed below. First of all, we need to read through the question carefully to understand what the question is asking. We need to use the given equation and know what each variable represents. Simplify both sides of the equation as much as possible. You may need to convert from logarithmic form to exponential form if needed. Use the laws of logarithms to solve for the indicated variable, or your rules for exponents for that matter. Reject any extraneous roots, which are solutions that do not make sense in the context of the question. And you should always state a conclusion and make sure that you've answered the question that was being asked. Many quantities in science are measured using a logarithmic scale, and two commonly used logarithmic scales are the decimal scale and the pH scale. This concludes our public exam review for Chapter 8. If you have any questions related to the content of any of these presentations, please pose them in the question forum and we will be happy to answer them for you. Thank you for your time and your attention, and good luck as you continue with your review.